Hi guys, hope you're fine and doing well. So today we will be discussing this problem from the LeetCode weekly contest, which is 288, and the problem name is maximum product after k increments. So this problem is comparatively easier as compared to generally the third problem that comes in weekly contests. So let's discuss this problem. So the problem tries to say that we are given a non-negative array of non-negative integers, which is nums, and an integer k, and in one operation we may choose any of the elements out of the array, and then we can increment it to 1. So we are required to return the maximum product of all after we multiply all the elements of the array, and we have to do at most k operations. And since because after multiplication the answer will be large, so yes, we have to modulo it by 10 to the power 9 plus 7. So let's see how we can do this problem. So like this is the first test case. So what we can do is we can choose any of the elements. Like we can just and the number of operations that we are provided is 2. So we can just perform this operation on any of the elements. Like we can choose this element and we can increment it to 7, and then we can increment this 3 to like 4. And so here we have done two operations. Now let's calculate like what is the product. So the product is basically 28 multiplied by 6, which is 168. But the actual answer for this test case is something like 216. Let me confirm it. Yes, it is 216. So how can this be achieved? So this can be achieved like when we make this 2 to 3 and then 3 to 4. So now if we do the product of all these numbers, it comes out to 216. So the main question arises is like how we will choose these indices. Like, can't we do just increment operation on any index? No, that's not the case. And that's the reason behind it is, let's consider we are given these only two elements and we can just perform only one operation. And now if we perform this one operation, if we perform this on 3, we can make it to 4. In this case, the product will be 20. And in case if we perform this operation on 5, then it will come out to be 18. 20 versus 18. So obviously 20 is greater. So by this example, we imply that we should always increment that element which is the minimum, right? So that is the same case that is being followed here. So the naive approach to do this problem will be something like we will just run a for loop from 1 to k, and in between this for loop what all operations we will do is we will simply sort the array. Here A is the array, and then the next step that we will do is we will just pick the first element of the array and simply increment it. And again, this loop will be performing the same operations up till k iterations. So the problem here is that the constraints that we are given is that the length of the array and k is of the form 10 to the power 5. So k is also 10 to the power 5 in worst case, and the length of the array is also 10 to the power 5. So if we calculate the time complexity, so for this for loop, it will take 10 to the power 5 operations. And similarly for sorting this array, it will take 10 to the power 5 and log of 10 to the power 5, right? And for this operation, it is just O of one operation. So if we just multiply it, so it will come out to be 10 to the power 5 multiplied by 10 to the power 5 and log of 10 to the power 5. So it is 10 to the power 10, and plus there will be some value of this log, which is definitely greater than 1, right? So as we know that for completing these operations in 1 second, so we are for 1 second there are generally 10 to the power 8 operations. So this will definitely give time limit exceeded. So this approach cannot be followed. So what other thing can be done? So the main problem that we are facing is like every time we have to sort this array, right? Because if we look at these k iterations, it is really difficult to avoid them. But if we look at this part of sorting, we are just sorting whole array because we just require the first element to be the minimum. So here is where the priority queue or the heaps will help us in minimizing these operations. So as we know that for heap or priority queue, if we build it, it will just take n to the n log n operations. And if we want to query it, like if we want to remove an element or update an element or add an element, it will just take log of n operations, right? So if we are provided with such a kind of data structure, our just task is to run a for loop from 1 to k, and then we will just and the function of the priority queue is that it will provide us with the minimum element out of all the elements that it has. We are required to do next is, let's make the variable v is equal to, we will just remove the element from this priority queue, and this element will automatically be the minimum element, and then we will just increment this element v, and again we will add this element to the priority queue. The priority queue will itself handle these elements, and next time we like remove any other element, so it will again provide us with the minimum element, which might not necessarily be this v, right? So let's analyze these operations. How much time will they take? So I will be using n for the 10 to the power 5 value. So for this for loop, it will just take O of n time, and for the removing, it will take log of n, and this will be O of 1 operation, and again this adding up operation will take log of n. So if we clearly analyze, after all these operations, our algorithm will just be reduced to n log of n, which is 10 to the power 5 and log of 10 to the power 5. So this value will just be like 14, around 14 or 13, right? So this is well under 10 to the power 8. So hence this is how we optimized our approach. So now let's have a look at the code. So firstly, I created the priority queue, which will store long type values. And here I have just added all the elements of the array to this queue. And then I just ran a for loop from k to 0. Then in this, I just created a value and removed the topmost element, which will automatically be a minimum element. And then I added this element to the priority queue again after it has been incremented. And after all these operations, after these k operations, I just calculated the product of all the elements available to me in this priority queue, and hence I just returned the answer. So this is how this code is working and it is being accepted. So I hope you understood the solution to this video. And if you appreciate my work, you can consider subscribing to my channel and giving thumbs up to this video. So let's meet in the next video. Till then, bye bye.